Okay, so again, good morning, good afternoon, good evening, wherever you are. Welcome to the roundtable focusing on the water sector and transforming the water sector with data analytics and IoT. And my name is Guy Meiri. I'm the head of business development of IOSite. We're based out of Israel, and we have a really great panel here. And I'm happy to moderate this session. I'll start with a little bit of an introduction, and then we'll have a few minutes for each of the panelists to present themselves, their companies, their point of view on the topic of this roundtable. And then we'll have some time, enough time for questions and answers. So if you would like to present a question, please do that in the chat box. And please direct the question to the specific panelist that you would like to get his answer. Um, so I hope you enjoyed this session, and I'll start by just sharing a few slides. Okay. All right. So I hope you can all see my slides. Um, um, I already mentioned what this session is about. And yes, we are in an Industry 4.0, General Industry 4.0 summit. And we are the water sector. So what are we doing here? Water is industry, but it's also part of the really critical things we have in life. I mean, our life depends on water, and clean water and sanitation is really one of the sustainable development goals that the United Nations has set forth for the coming year. It's clear, it's important for everyone globally. I mean, water challenges are not just a matter of developing countries. They're also a challenge of developed countries around the world, all the continents, and therefore we also have some people from different countries on this panel. And the digital war, you can ask what does digital IoT has to do with water. There are a lot of challenges, a lot of drivers for adopting digital technologies in water. Maintaining water quality is a critical one. Providing access to clean water, maintaining operational efficiency or ensure operational efficiency in order to also provide affordable water. It's another great driver of digital transformation, and obviously protecting the environment. So all of these across the various, say, entities in the ecosystem of water, like water and wastewater utilities, desalination plants that we know so well in Israel, watersheds and environmental agencies, all of them share these digital transformation drivers. And on top of it, as I mentioned, it's also water also has, it has industrial type, very complex, data rich critical operations. For example, wastewater treatment plants or desalination facilities. We see here two examples that we have in Israel. So again, on that aspect, water is like any other industry, complex, data rich organizations. Um, and facing the same challenges, like a lot of systems, lack of synchronization. How do we turn data that we might have into insights, into decision support? All of these challenges we're going to talk about today. Specifically, our company, that's what we do, IOSite, and that's the only slide I'm going to have about our company, IOSite. What we provide data management and analytics for water entities, exactly for that, taking the data, arranging the data, cleansing it, and really serving it to support decisions across the organization. And the panelists that we have today include them, that you'll see in a minute, include Amir Riggs from Wessex Water in the UK, Ben Stanford from Hazen and Sawyer in the United States, David Malgay who manages the Hadera desalination plant in Israel, Ronen Schechter, the co-founder and CTO at Fluence, and Subir Bachattarjee, who is the founder and CEO of IntelliFlex Control in the United States. And I hope you enjoy this session. And with that, I will hand it over to Amir.
Hi all, good afternoon. Good to be here. I'll share a short presentation about Wessex Water, a bit about myself, try to be very concise with it. So yeah, I came to the UK around a year and a half ago, joined Wessex Water to build the IoT Competency Center. My personal background is mostly from R&D in the IoT, telecom, networking space. I've worked around water, but mainly in agriculture systems, less from the operational side, which is, it makes it a bit different for myself and a great learning opportunity. A bit about Wessex Water. So in the UK, we have 10 regional companies. Our specific location is in the southwest of the country. We are under regulations of Ofwat, working in 5 years plans called AMPs. This is the way that we work in the UK. 12,000 kilometers of water mains, 34,000 kilometers of sewer pipes, 8 million pipe work joints, around 400 sewage treatment works, and around a little more than 2,000 pumping stations. We serve around 3 million customers for water supply and around 1.4 million more in sewage. Just looking at what Guy mentioned before, we are now looking into our digital transformation space, actually trying to make good use of machine learning and analytics. This is an example for rising main bursts experiment and POV that we are running and showing good results. Our water supply optimization dashboard that you can see here. So what I'm trying to present is the new technologies that we have in our business, and this is just the beginning. We're looking forward to adopt many more of these. Here you can see our smart grid results with its quick responses, right, where we try to early detect and prevent service disruptions. Here you can see an indication on a rising main burst that we identified using a machine learning model. And this is a nice example on using machine learning on alarm analytics. So the control room gets hit in our kind of companies, gets hit with hundreds and sometimes thousands of alarms, and the human resources are scarce sometimes. We don't want to recruit more and more people. But on the other hand, we have more and more devices. The devices get more and more complex, and we'll get more alarms generated by them. So we need to control it better. Right, another nice example. Last but not least, we use other technologies in order to attain more telemetry and data from sites, be it drones and trucks that can go to specific locations. So not only stationary outstations, but also portable outstations and portable sampling trucks. All of these are interesting for us to understand the quality of our water, the quality of our pipes, and make sure that we operate in an efficient and quality manner. Well, that's all for myself. I tried to be concise. I hope it was clear, and happy to join this panel, as I said before.
Thank you, Amir. David, your turn. You're on mute, David.
Good afternoon, everybody. It's a pleasure to be here. Thank you for having me. Again, I'm the CEO of Omis Water, Hadera Desalination Plant, one of the largest in the world. I'll just share a quick presentation. Okay. Hadera Desalination Plant, which was actually designed and built by ID Technologies. A few words about ID Technologies, established in the...
David, just want you please swap the display settings, swap between the screens, the top of this. Go to the top, swap, the one next to it, the middle one, display settings, swap, exactly.
Okay, sorry.
That's all right.
Okay, ID Technologies, established in 1965. In the 80s, was private. The company was privatized. They lead technology in desalination, industrial water treatment, wastewater reuse projects all over the world. They've got a very large and growing portfolio of patents. They've got IDEA's offices in Israel, based in Israel, headquartered in Israel, offices again in China, India, USA, Canada, Chile, Australia. They've got more than 500 installed units in over 40 countries, and the ownership today is Alpha Partnership Waters, after the company was bought out from ICL and Delek. A bit about Hadera. The capacity of Hadera, the contractual capacity, is today 137 million cubic meters of drinking water, 18% more or less of the domestic water consumption in Israel. Reverse osmosis technology, it is a BOT project, the partnership between the private sector and the public sector over 25 years from conception. We are located in the compound of the Orot Rabin power station in Hadera, Israel, central Israel. And the plant was commissioned at the end of 2009. Building the plant, well, there were quite a few achievements at the time when the plant was built. First of all, Hadera is one of the largest operating seawater reverse osmosis plants worldwide. I won't say second or third, but it's in the top 5. Lowest cost of desalinated water in BOT projects. The tender which was bid for the price of the water. A very short construction period, 28 months took to build this plant. And at the time, it was in 2007, it was the finance deal of the year. A very narrow footprint. We were given actually the backyard of the power station. Whatever footprint was left for us, that's what we took. We overcame very demanding constraints of space. We are 1.25 kilometer long and only 100 meters wide. We have 2 separate treatment facilities on site, a 3-center design concept, high pressure, RO, and energy recovery system. And after that, we have on both sides cascade boron treatment, removing excess boron from the seawater. And I think the most important thing, especially for this event, we have at any given moment around 55,000 data tags which are collected online all the time, and we also relate to those data tags. I think that's my presentation, and actually our challenge is how to get more out of those 55,000 data tags. It's something that we're working on all the time. We have been working from the start on improving the way we relate to those data, and I think we're doing quite a good job. Back to you, Guy.
Okay, thank you, David. Next is Ronen Schefter from Fluence. Ronen, the floor is yours.
Okay, a minute to get my screen shared. Hope you can see it just fine.
Yeah, you're good.
Good. Okay, so I'll get right to the chase. I'm here to represent, David, please mute, thank you. I'm here to represent the water industry side of the discussion, less so the digital component for it. Just in order to bring the need and an opportunity and a vision into the future to the discussion. So Fluence Our company is a global company focused and specializing in decentralized solutions for both water and wastewater treatment. And just to get us all up to speed or on the same page, let's take a look at a few of them. So I'll just run through. No details, nothing, it's all written there. These are decentralized systems in different places, different sizes. Nice thing is they're all based on the same building blocks. You see the containers. This is the heart of the system. Usually there's some building with the instrumentation, electricity, accessories and stuff, but main building block are these containers. That's the concept we're promoting. And these are the decentralized systems. So there's two edges, two sides, opposites to planning a wastewater management system. One on the left is the centralized one. This is the most common approach for engineers globally. And there's the one on the right where we have several decentralized systems instead of the centralized one for the same area or region. So each one of them has its own advantages, like the decentralized one that we were promoting has lower infrastructure costs. You can see there's much less piping and much less pumping of both the wastewater and the treated water back for reuse. So less energy for the pumping. It is a very significant component in OpEx. So on the other side, the centralized plant, one big plant enjoys the economy of scale, so lower plant cost, lower equipment cost. Less operators probably because you can operate just one. And regulators like it because it's just one plant to regulate. But I think that technology and digital and correct management can actually reduce or remove the advantages of centralized, and they have decentralized meet all of these advantages just as well. So why are we looking at this decentralized and where is it going? One decentralized plant is less interesting. What I just showed, that several plants provide the same service, is more interesting because it becomes complicated to operate. So why consider it at all? And the reason is just cost. Look at the costs here. If we just compare scenario 3, which is completely distributed, shown on the left, and a centralized one shown on the right, this is actually a case study we did for where I used to live before, in Tivon, in Israel. So two approaches. And if you compare the life cycle costs of operating and investment, you see that the distributed is something like 25%, almost 25% lower, or the centralized is actually 25% higher than the distributed one. So there is incentive to go there. And I'm not the only one saying that. This is just one example of really many publications that I can share with anyone interested, how people actually calculate and simulate a very complicated combinations, any combination of terrain like flat, hilly, or mountain, and population density, rural, suburban, or urban, to find the optimal cost. And you see that it varies. For the rural population, usually it's one plant per household, but surprisingly in the urban population, it is somewhere in the middle, something like 1,000, couple of thousand cubic meters per day per plant. So this is something being discussed because the cost is very attractive and a strong incentive. But what are the challenges? Why is this not the default way that engineers go? Why do they still prefer and go to the centralized planning? So I think we're not there yet. We need to get the concept of distributed treatment with centralized control using a physical component and a digital component offered as one solution together to become available for vendors and customers. Once this is possible, it will win on cost. This requires a partnership between the physical product providers and the digital component providers. So this partnership and development of a full integrated complete solution will actually support this transformation because there is a very strong cost incentive here. So that's the point I wanted to make. And I see this in our future. It must happen because the advantage is so big. Thank you.
Thank you,
I
Ronan.
need to stop sharing, right, and mute myself.
Thank you. And Subir, it's your turn. You're up. You're on mute, Subir. Oh, yeah.
Thank you, Guy. And thank you for having me in this session. And I will open up my slide. Hopefully, you can see my slides, right?
We can see it well.
So my name is Subir Bhattacharjee. I am the CEO of IntelliFlux Controls. Our business is delivering intelligent self-learning plant automation or autopilots for chemical process plants, with water being a very core segment of our business. We started our business with automation of water treatment plants. We do digitalization, but the way we brought digitalization in the water industry, especially the decision automation concept, was by trying to develop the business model for this. And what I will talk about perhaps touches a few ideas that Ronan shared, and we have experienced some of those issues, the connectivity between the physical and the digital system. And we try to implement those digital solutions in existing plants. So imagine your process plant became smarter tomorrow, allowing it to do a bunch of things like respond to upsets in an autonomous manner, optimize the operation depending on supply and demand, diagnose process or maintenance problems, guide the operators, generate reports, automatically reduce in-plant workforce, which will give you tremendous ability to achieve better energy management and hence energy savings, chemical savings, waste management, and overall reduction in OpEx, and fundamentally improved reliability and sustainability for your water treatment plants and assets. So IntelliFlux went to deliver this PDP loop closing system, and we developed a software-based plant operating system which can install on existing process plants pretty much with no addition to the plant hardware, delivers improved plant operations from the first day, and causes no disruption in the current operation. And in this exercise, as we are doing this for the last 3-4 years, we have been able to deliver process control. We acquire data from the plant, but an interesting thing is that most of our customers pretty much focus on how can we see what the automation is doing. So we put in a lot of monitoring, analytics, and reporting to augment the basic process control PDP loop closure that we are doing with our Smart SCADA platform. The results are pretty obvious from what we have done. For food and beverage industry, in a beverage processing plant, we are routinely saving 40% plus water at the plant's filtration facilities and water treatment facilities. At a wastewater treatment plant in Middle East, we are saving about 32% energy based on reducing aeration demand and basically automating the aeration based on the COD and whatever the wastewater treatment process demand is. During the recent COVID in South Korea at a plant, we basically had the plant operating for weeks with about 67% fewer on-floor support staff, because the city's folks were quarantined. They could not go to the plant. They had IntelliFlux installed, and they basically could monitor the plant remotely. They were seeing normal operations, and operators only went in when consumables needed to be filled in or any maintenance alarms were set up. So these are the small examples of implementation of what we call the physical to physical loop closure with improved automation that is the ultimate goal of Industry 4.0 in the water business. And a lot of the sustainability divisions in corporate water management across global companies, as well as water utilities, are warming up to our idea. And we are working with this. As a startup, we are at the bottom of the food chain, but we are working to become a leader in terms of getting the ideas of intelligent automation and fluid robotics for the chemical process industries into the water treatment business. So I'm looking forward to the discussion. And again, Guy, thank you for making me a part of this panel.
Thank you, Subir. It was very interesting. And last but not least, Ben Stanford from Hazen and Sawyer. Hi, Ben.
Great, thank you very much. Let's get these slides up. Are they on the screen? Oh, how about now?
Yeah, we're good.
Okay, excellent. So thank you again, and it's great to be here today. Just wanted to talk about sort of the consulting perspective on this and how we are working to get water and wastewater utilities to integrate systems together to really facilitate decision making. Our vision for smart water utility is really all about the people, and it's about connecting people with each other and with information to solve challenges. And that can be done really through a centralized platform where you're bringing in your GIS maps, your asset management systems, SCADA, water quality, customer, financials, all together so that you can enhance your visualization, decision-making, understanding of the system, and really thinking about this moving forward. And so I just want to briefly show you a practical example of how this works for us. So the image on the right, both of these are videos that I'll play. This is what we call a single pane of glass. And I'm actually going to start rolling this video here on the left, which is this first tab. This is for a water utility. And what we're doing is bringing in the data that they already have through a single portal. So we're looking at the building information models, the Revit files, whether it's a 3D one like this one, or whether it's a 2D CAD drawing. We're bringing that together so that when the utility is designing or looking at the facility and facility options, they can actually get a better feel for what that's going to look like, how that's going to be imagined when they're in it. And then bringing that right over into the single pane of glass concept, where they can now take their information models, and as they're being edited and commented on, they can use products like Assemble, which you see over this tab on the right, where they can actually gather and capture that information. The reason that's important is that as you build the facility, inevitably there are going to be changes. Different equipment's brought in, different pipe sizes, whatever, and we want to be able to capture that. So the single pane of glass concept is really all about bringing these assets together. So it's pulling the geographic information system so you can look at multiple facilities. For this particular utility, they have 7 wastewater treatment plants. You can use that CAD file for understanding the facility, understanding critical assets. You can color code them. You can understand what's happening with them. You can use that for training. You can also use 360-degree photos inside new facilities, inside old facilities to understand, again, for training, for confined space entry, whatever you need to be able to understand what's happening there. And then lastly, tying in dashboards where we have better control of the assets, the computerized maintenance and management systems, and then of course things like the Power BI dashboard as well. So it's really a great way to pull all of these processes together, but the way that you do that is through a strategy. So it's understanding what are the key things that you want to address, how do you manage the data, how do you use that in a way that's cost effective and provides the best stewardship of the resources for the utility. Of course, making sure security is there, being innovative in that approach, and then providing support. So that last piece is really important in that we use entirely commercial off-the-shelf technologies. We're not building anything new. We're just using the inherent capabilities of those technologies to bring those processes, bring those people together, so that rather than opening 5 or 6 or 7 different programs, you can, again, go through this single pane of glass concept. So when we think about that, again, it's all about the strategy and understanding what those benefits are. So from the utility space, whether that's a water utility or power utility, you're looking at improved operations, improved efficiency, improved reliability. You're looking at better decision making. You're looking at understanding what those key performance indicators are and providing a way to act on those so that as you move forward, the alarms or whatever it is can be dealt with in a way that's increasingly efficient, increasingly productive. Improve your asset management and maintenance systems. Really lets you, with that strategy, develop the forward-facing IT infrastructure so that you have the capability to do single pane of glass applications. You want to create an innovation culture. That means that everybody's thinking ahead and thinking about how to bring these pieces together. And then lastly, you want to enhance your connection with customers, whether those are internal, all the different groups within the utility, or your external customers. So that's just a brief view of our thoughts on innovation and how we want to pull that together. So Guy, I will hand it back to you.
Thank you, Ben, and thanks for all the panelists for great presentations. And we'll get to we're gonna take questions from the audience, but we also have some questions we would like to share. So whoever is in the audience can please write your questions in the chat box to whoever you want to answer that. But let's start with a question, and let's start with David. So David, what are your main priorities when it comes to implementing digital solutions? You mentioned the 50-something thousand tags you have, and we know you quite well. So, what are your priorities?
It's a very difficult question to answer because we are literally flooded with information. We've got even more than water at the moment. We've got lots of information floating around our facility. And after my first actually challenge is to identify what are the critical issues which I have to address. We can get more input into predictive maintenance, into operation optimization. Energy is a big factor for us. Of course, how to optimize on our consumption of energy. So there are lots of different ways how to use that data, and we're getting there. We're now looking at predictive.
All right, thanks, David. And Amir, same question goes to you about your priorities.
Well, our priorities are, well, first of all, to make good use of our data. So we've been collecting data now for over 20 years, but with older technologies, using older devices. We've been installing newer and newer kit. As time passes, this kit will send more data, but we are not smart enough to make good use of this data. We store it, we maintain it, but we don't extract the value that we should be able to. So that's the first priority. Another priority would be in cybersecurity. So making sure that we catch up with the new realities around the world, and make sure that also our older kit and of course the new one are compliant with our government regulations, the NIS regulation, and yeah, and of course budget. Budget would be a priority as well.
Okay, thanks, Amir. And so budget when it comes to digital solutions, or budget?
Yeah, when it comes to digital solutions, when we look at the digital transformation from for example, on-premise servers and on-premise applications, migrating to the cloud, making use of all these new goodies for machine learning and artificial intelligence and analytics, all of this incur costs, and it's not a simple task to compare on-premise costs versus cloud costs. Not as simple as people may think. If you need to calculate human resources involved and procedure length and redundancy and resiliency, all of this come into play when you well, when you take into consideration which parts you're looking to migrate, definitely looking into not a single decision of moving everything, but a hybrid approach based on proof of values and proof of concept before you go forward.
All right, thanks. So the next question goes to Subir. Subir, when you're like your clients are facilities and they're dealing with the types of challenges that David and Amir just talked about. So when you reach out to them, when you start engaging with them, what would be your expectations? What do you think they should be thinking about when they think about digital transformation?
Question. It's wildly varying depending on geography. What is the background of that customer? Which setting the customer is coming from? So it is, if it is, for instance, municipal or public utility, the expectations are different in terms of how the operations should be managed and what would be the role of data for such a centralized facility. If it is an industrial corporate sustainability group who are looking at managing the water assets across their base of operations, or let us say our example with Nike, where we are working with their corporate sustainability group, where they are telling their suppliers to comply to zero discharge regulatory limits, and they are trying to benchmark their plants across the board in various countries in Asia to bring to same operational culture. They are each different, and we work with these clients in a very systematic way, top down, from a corporate down, to figure out. The first question we ask is very simple. What is the value of data and digitalization to you? Why is it different from your status quo, how operators are working? And the feeling I get always is there is very poor understanding in the water sector and in many chemical industries about what Industry 4.0 or digital transformation actually means. And it is mainly embedded in, oh, more people will look and analyze historical data. Well, we have been analyzing historical data for 40 years since SCADA Historian was there. The whole idea is putting data into context and making data actionable in real time is a very important thing. So when you take real-time data and convert it into real-time actions, that translates to reliability. And that has happened with ERP systems in business, right? So we are trying, that is where we go to the corporate customers and try to tell them that, look, can you build an ERP system for your assets and try to manage it? And I think some of that was sort of brought into focus from the discussion of Ben. And I think that it has to be looked at holistically across all the stakeholders. The company needs to connect, or the utility needs to connect with respect to its data use. So I hope I answered your question. It's a very big elephant and everybody sees it in very different ways, is the short answer.
Yeah, it's obviously very difficult to answer such questions, in a very short answer, but it was actually quite interesting and quite a nice perspective from my personal as a listener here. So the same question goes to you, Ben. Same question I just
Yep.
asked you. Your expectations?
Yeah, no, that's a great question. So I think what Sabir was saying was spot on. It's really all about understanding the problem that needs to be solved and starting with that. And oftentimes utilities get stuck on looking for big problems. The way that we approach it in some of our smart utility strategy meetings with our clients is really just doing some simple surveys of staff and helping them think through, how long does it take to get data? How long does it take to work with data? How long does it take to manage the system? What are your desires? How much does technology improve your job? And those can be really simple key performance indicators that are used moving forward. Again, you've got to pick technologies that answer the question. And with one of the utilities where we did this survey recently, their biggest thing was about a third to half of their staff were spending anywhere between 3 days to a week or more to get data and analyze it. And if you can shorten that, that's faster decision making. That is less time that people spend working within their platform or within their solution. and are able to facilitate that decision making. So you're looking at enhancing people, you're looking at enhancing people's jobs, not replacing them. And so my expectation is that utilities are thinking not that we want technology A or B, but that we want to be able to solve these various problems, and then you help find the technology to do that.
All right. Okay. Good answer. Thanks. So next question goes to Renan. Actually, it goes to David, not Renan. We'll get to you soon. David, you already started your journey, okay? So we know that because we work with you. But where did you start, and how do you see the path forward in terms of your digital journey?
I'll go a bit backwards. I started the journey around 30 years ago, when I started filling management roles in various industries, chemicals, paper, building industries. Sorry, I'm a bit hoarse. Wherever I went, there was always data, there were always systems. I started off with DOS run systems, moved over into Windows, then ERP, before that MRP, BI systems, and now we're on industry. We've got to Industry 4. Everybody has mentioned the same factor. There's a lot of data, and data is an asset. Whichever way you look at it, the data is an asset. Our main challenge is to optimize all the potential that we've got in all of our assets. I mean, if I've got a pump and I measure its efficiency, and we all understand 95% efficiency of a pump, getting more of what we put in it, why not do the same thing when it comes to data? We've got data, it's an asset. We have to get, well, how efficient is our data? So at the moment, we are looking how to get that data and how to start using it. Ben mentioned the people, of course, the people. That's the first issue that we have to address. What do people need out of the data? How do we get that? We've started using systems, your system as well, and to get more out of data. Presently, our plant engineer, he's looking at data to forecast when will a pump go wrong. When will something happen? When are the vibrations getting over a certain limit? So it's an ongoing process. It's not something that starts now or started half a year ago. It's something that's going to continue at least for the next 5-6 years, and then we'll get to something new.
Thank you. So basically, you're saying is your priorities are almost all of them are focused on the data itself and the utilization of data for specific,
sure, definitely,
specific objectives, basically use cases.
That's our development data. We've got a few other objectives in the company.
Well, in the digital space, I mean.
Yes, of course.
You need to provide water. That's basically also another objective. So, Ronan, the next, actually 2 questions will go to you. You were waiting patiently, so now you get 2 questions. So first question would be when people like Subir or Ben or their companies, technology providers or service providers approach you and say, kind of like, let's help you with your facilities, what would you expect from them? It's kind of like the flip question to the one we asked them, what do they expect from facilities and utilities? So it's the reverse question. So maybe you can answer that, and then I'll present the second question. You're on mute. All right.
Sorry. So I'll start with the obvious. So primarily, of course, everybody wants system integrity, stability, reliability on the mere presentation and reporting of data. Data has to be accurately collected, processed, transferred, presented, and enable the operator to view it and react to it. Sounds trivial, but it's a place we see, systems fail. Secondarily, the solution, like this subsystem, this component, digital component, should contribute to operational reliability and efficiency through algorithmic intelligence, smart systems, anything that can be applied with some level of processing, algorithmic processing of data, and support operators in selecting their actions would justify an investment, a serious investment. This is very general. So going into this new application that I'm trying to develop. So I would expect vendors and developers in this field for the digital component to customize their platforms for a general application in a way that will enable them to replicate it many times over quickly and cost efficiently. So this is the partnership that I mentioned in my presentation, that I think if you aim for a market segment, you develop together a customized product for it, and then it requires very little work applying in every project. This will help implement it commercially.
Thank you. Thanks, Ronan. Very interesting perspective. Also thinking about it from what I know from our company, from our site, customizing. I mean, we have a generic platform for water, and we applied it across the industry. I'm thinking about, is it, can we productize it for specific segments, like you mentioned? So we have a lot of desalinations, obviously we're there, but it's a good point. And the second question goes to you is about the role of the regulator. And we have a question is, do you see the regulator as an accelerator, an inhibitor, has any impact, no impact? What is your perspective on the role of the regulator?
This is a very interesting question with a complicated answer. Usually, regulators are sort of market makers. They pose new requirements, and the consequence is new projects for improving treatment processes or installing additional capacity and stuff like that. In that case, they're accelerators, of course. But in this specific, my specific experience with the distributed concept, at least in Israel, there is very strong opposition from the side of the regulators, and it takes a lot of convincing, and they pose a lot of requirements against having many separate systems, distributed systems. So in this case, they're a bit of inhibitor, but this can be overcome. It just takes more work.
Okay, so thanks. Interesting perspective. Amir, next question goes to you, and we step a little bit back. And when you look at your priorities and I would say, it's the question of what are your priorities and also how you approach it. I mean, how could it be that you want to have a very, I would say systematic, methodological, top-down strategy, which is then broken down into initiatives and projects, or you're in maybe a process of piloting? What is kind of like your take on first of all, where are your priorities and how you are actually going about that?
All right, so at least in Wessex Water, which is relatively to water utilities, at least in the UK, has a good appetite for innovation and technology. We actually have both approaches. So definitely we have the top to bottom approach where we have the business objectives. Some of them are derived from our regulator, and we need to match and make sure that we meet these objectives in our 5-year plans. So we break it down, use Hoshin metrics for that, and it's a tedious work, but then we can make sure that we meet these objectives. But in order to create value and make sure that we have also the right pace, so specifically in my domain, in IoT and technology, we definitely work in POC and POV, so proof of concepts and proof of values. So we have sprints. We try to dedicate between 5 and 7 weeks to each such experiment, where we try to build something on test dev environment. We see if it works for us, if it creates value to the customers. We of course involve people from the business, so from engineering and operations, to make sure that they are the users. We understand them, we see that it works for them, and then we immediately decide if this is what we call a learning opportunity, but needs to be dropped, or something that we can adopt. So actually we have both approaches that I just said.
Okay, good. So we have kind of like about 2 minutes or 3 or maybe a little bit more. So I'll present 2 questions, and maybe we can just like each one just say, a very succinct answer about those 2 questions. And the 2 questions are: what are the critical success factors that you see in implementing digital solutions, and what are the key obstacles? And we'll start with David and then continue from there.
2 questions, 1 answer: people. The critical success factors are people, and the issue has to be addressed. I've implemented in the past ERP systems, and it was always a question: if you onboard the people on time, properly, you will succeed, whatever the tool. And if you don't, you will fail. It's just as simple as that.
All right, thanks. Subir?
Succinct: people and systems view. Digitalizing, so people has been addressed by David. It's critical. People need to adopt the technology. The systems view is very important. Digitalization cannot be properly implemented if software people who are not cognizant of the needs and questions and demands of the water industry try to toss in algorithms, and there's a communication gap. So there needs to be intense synergy between the people who come from the process industry and who come from the digital space to talk a common language and develop a solution that works for both. I think that has been a major gap so far that I have perceived. So those are 2 points.
Thanks. Interesting. Amir, what is your perspective on that?
Well, it's try not to repeat what people said before, but I agree with what was said before. I can also add that you need collaboration inside the business. So a company is with 2,500, 3,000 employees. You have tension between operations, between engineering and IT, and the collaboration and the tools is very important. So it's on top of having good people and with good attitude, you need to have tools in place that actually enable these cooperations and enable us to prove the value, as I said before. So I would look into this. An inhibitor, well, the regulation, as mentioned before, could be an inhibitor where we like to advance, but you're not allowed to. Our business is, of course, life-threatening if you take the wrong solutions. We have UV, we have chlorine involved, so you definitely don't want to play with these, right? So you need to have, it is an inhibitor, it is a needed inhibitor, but it's still there.
All right, thank you. Maybe just a question for me. How do you see cyber? I mean, because there's been discussions about cyber recently.
Well, cybersecurity is a raising concern all over the world, especially also in the UK. I can share that inside Wessex Water, only last month we decided to construct an EU unit inside IT to take care of information security in a more wider business-wide perspective, recruiting more people into it and making sure that the compliance and and governance of the issue is growing. We now have the NIS program, the NIST program here in the UK, which we all must adhere to. It covers both hardware devices, or devices side edges, and of course our systems, be it the cloud, on-premise, our security, digital and physical security, all is covered by this new regulation.
I agree with that point. ISMS is something I found missing in a lot of our customers, and we were surprised when we went in and asked, what is the cybersecurity framework that you adopt for your digital space? A small fraction of customers work in that space. And one of the solutions that I have seen primarily in the utilities sector, like PUB Singapore, or governmental agencies, or in US, for instance, utilities, they work in a framework which is typically called the air gap, which basically means no wavelengths of data gets outside the premises, right? So those types of absolute clampdown on data, which completely precludes cloud, becomes a pretty major obstacle to efficiently and inexpensively implementing digital technologies. And so those are the things that are evolving. I take part in IEC 27000 and those types of cybersecurity protocol development meetings and discussions. And I think they are making progress, but it is a rapidly transitioning area, and it is a major thing that one needs to keep in focus. Utilities are critical assets, and one can just have a hacking issue which could cause problems.
All right. So maybe the final 2 minutes, Ronan, maybe you can pick on that point because probably you have something to say about that.
I think that both the success factors and obstacles are associated with two things. One is the cost to benefit. I mean, once this is justified technology, nobody is really afraid of technology. People are afraid of risk. And if you can't put their mind at rest, this is what they're concerned about, not technology. That's my view on things. Second is the matter of maturity. Maturity includes what Subir mentioned, I think, before, or was it Amir, that both sides understand each other, the utility side and the IOT, or the digital companies. So as long as the digital providers think that utilities don't understand anything, and they probably don't. It's a matter of maturity. Once it's mature, they do, and vice versa. Until you really know what's bothering them, what's stopping them, you're immature. You're immature. And you're all muted, by the way.
We're being thrown out of the room, so I'm sorry, Ben, we kind of couldn't give you the final note, but
no problem.
But thank you, everybody. And I'm not sure if we're still live or not, but I'm getting a lot of signals that we're soon going to not be live. So thank you. It was a great discussion from my perspective. Thank you for joining. Thanks for the audience for being here. And I think there's probably going to be another audience in the other. It's going to be, broadcasted at some point. So thank you, everybody. And well,
on demand.
On demand. See you again soon.
Thanks, everyone. Bye.
Bye.
Bye. Thank you. Bye-bye.
Bye-bye. Cheers.